Temperature. Some things are hot and some things are cold. What's the difference between hot things and cold things? Well, we measure temperature by degrees, either Celsius or Kelvin or Fahrenheit, and what temperature really is measuring how fast atoms move around. And the faster atoms move around, the higher the temperature. So you could think of a time when the atoms are moving around really fast and there'll be a high temperature, but if they're not moving at all, it would be a really low temperature, and that would be the coldest it could get. And that is called absolute zero. And that's where we start measuring the degrees in Kelvin. 0 degrees Kelvin is the same as negative 460 degrees Fahrenheit. So 460 degrees Fahrenheit below zero is where atoms basically stop moving. And you can't get any colder than that. Now, we can think about what happens if atoms are moving really fast. Okay? They're going to bump into each other more often. And if they're moving slow, they're not going to hit each other so often. So chemical reactions happen when atoms bump into each other or molecules bump into each other. So you can actually slow down chemical reactions or speed them up depending on what the temperature is. And so today we're going to take a look at the effect of temperature on chemical reactions. So I have light sticks because light sticks just look cool on TV. And I've got 3 light sticks. They're all the same color. And hopefully they're all the same brightness. And we're going to compare them here. They're all the same temperature right now because they've been sitting in the air. So you can see here that all 3 light sticks are approximately the same brightness, and of course they're all the same color. So we're going to take one and we're going to set it just in a jar and let it sit there at room temperature. We'll take another one and we're going to put it in this hot water here that's almost boiling and let it sit there. And we're going to take the last one and we're going to stick it down in some ice. And we're going to let that sit there. And let me flip this around a little bit more heat in there. Well, guess not. I'm going to set that in there. And we're going to see what happens over time as each one gets colder or hotter or stays the same. And what we're looking for here is for the atoms in the cold one. The atoms in the cold one are going to get colder, and so they're going to slow down. And the chemistry is going to happen slower. All right, these are going to be the same rate that they always were. And the light stick in the hot water, the atoms are going to move faster, and so their chemistry is going to happen faster. Now the chemistry that's going on is a reaction that causes light to happen. So the faster the reaction, the more light that will be given off. And so even as we've just been letting it sit here, you can see that this yellow one here, even the bottom half is just bright compared to the top. So if I spread that out, you can see it's just getting bright because it's warming up, and so the chemistry is happening faster. This is still the same, and then the cold one is slowly cooling off. All right, so if I quickly compare the 3, you can see that the 3 temperatures, okay, the hot one clearly is much brighter than the everyday temperature one and the cold one. Now let's let them sit there for a little bit and we'll come back and see what happens after a little bit longer period of time. We're back now and we have the normal temperature light stick, which should be the same brightness that it always has been because it hasn't been too long. And then as we compare that, we can then begin to compare it with the one that was in the ice water. And hopefully the ice water one, there it is dimmer because it is colder, and so the reaction's happening slower. And then we compare it, of course, to the nice bright one that is warm or almost hot, and that's because the molecules are moving fast, and so the chemical reaction can happen fast. You make spaghetti by putting it in hot water. That's because the chemical reactions that soften the spaghetti you want to happen fast. So you put it in hot water. You could make cold spaghetti. It would just take you all day. So until next time, remember that higher temperatures have faster moving atoms and molecules. And so because of that, chemical reactions will happen faster at higher temperatures.